her. Okay. Hello, my name is Ilu, and my teammate is Minhui. In this project, we are doing natural language processing with disaster tweets. Next. Internet has been part of our life, and most importantly, Internet is where everyone gathers news and information. There are many resources on the Internet where people can get news and trends, and one of them is Twitter. Twitter allows users to express their emotions, what they're up to, and sometimes the emergency they are observing in real time. Flawed news or information can be misleading, and there are always people who tend to trust them. The goal of our project is to implement some natural language processing models that predict a given tweet is about real disaster or not. Social media companies like Facebook, Twitter has developed similar algorithms to keep track on what people are posting on their pages. And we wanted to apply what we have learned in this class into some real life situations.
Before conducting our project, we have done some research on previous work. In this related work, we find that in the context of text classification, neural networks can outperform traditional machine learning algorithms, and RNNs can outperform CNNs. Also, compared to LSTM, the combination of bidirectional LSTM, attention mechanism, and the convolutional layer can remarkably improve the accuracy of models. As for word embeddings, BERT can have a better performance than word-to-vect. The dataset we are using for this project is the disaster tweets dataset. It is sourced from a Kaggle competition natural language processing with disaster tweets. The dataset consists of tweets about disaster and binary labels classifying whether the disasters are real or not. Therefore, the goal of the dataset is to find the real labels for these disaster tweets. The dataset is split into a training set and a testing set. The training set has 7,613 observations, and the testing set has 3,263 observations. Before the modeling part, we have to see what these tweets are. So tweets have the word limit of 280 characters. They have complex semantics, and they may contain a lot of emojis, abbreviations, URL links, and mentioned accounts. These features make tweets hard to process, but thanks for the natural language processing libraries in Python, such as emoji. These libraries help us to clean the tweets. For example, in this screenshot, we can see that the library emoji help us to decode the emoji thumbs up into English word thumbs up. After cleaning these tweets, we can have a look at the context of these tweets. For example, there are two word clouds of disaster tweets. The left one is disaster text, and the right one is non-disaster text. We can see that there are more negative words in disaster tweets, and there are more positive words in non-disaster tweets. For example, there are love and laughing in the right picture. Also, we can see some famous disasters in the disaster tweets, like the Malaysia Airlines and the California fire. The next part is the modeling part. So at the beginning, we thought that we could use GRU and LSTM to solve the classification problem. However, no matter how we modify our architecture, the highest accuracy we can achieve was only 70%, which is really low compared to our goal of 83% of accuracy. So we seek help from the previous work. We found that bidirectional RNNs can improve our performance. Therefore, in this project, we decided to use bidirectional RNNs and BERT.
There are two kinds of word embeddings we have used in this project, and we wanted to make a comparison. Glove is an extension from word-to-vec, Both Glove and Word2Vec embeds word independently. The difference between the two is that Glove is trained based on the entire corpus, while Word2Vec is trained based on the local context. Also, Glove has the advantage of capturing sublinear relation in the vector space where Word2Vec cannot. BERT is another word embedding technique that people uses. Unlike Glove and Word2Vec, BERT embeddings word that captures the context of the word rather than embedding them independently. There are a lot of different BERT that are available to use. And for our project, we have used BERT based uncased. GRU and LSTM are commonly used for natural language processing. But one downside is they are unidirectional method and can only preserve information from the past. This can lead to difficulty in understanding the meaning of a word. So let's look at the two example sentences. Daniel loves apples. This is his favorite fruit. Daniel loves Apple. The company produced the best electronic product. Both sentences contains the word apple, but with different meanings. With unidirectional GRU or LSTM, machines would have trouble understand what is the true meaning of the word apple in each sentence. But with bidirectional, it will create a new layer and reads the sentence backward, which will help to understand the context better.
So in our project, we conducted 4 experiments with 4 different architectures. The first architecture is only about birds, and after the bird layer, we simply continue with the dropout layer with 20% dropout rate and some dense layer. Also, the second architecture is simply about bidirectional GRU and bidirectional LSTM. After these 2 layers, we simply continue with a 20% dropout rate dropout layer and 2 dense layer. The third and fourth architectures are very similar. It combines embeddings and bidirectional LSTM. For the third architectures, we use Grove for embeddings, and for the fourth architectures, we use BERT for embeddings. Therefore, we can compare the performance of Grove and BERT using the third and fourth architectures. In the third and fourth architectures, we also use the spatial dropout layer, and dense layer. One common thing for these 4 architectures is that the last dense layer only have 1 unit because the problem is a binary classification problem. So there are 2 pictures showing the first and second architectures. In the first architecture, we have the BERT layer, the dropout layer, and free dense layer. In the second picture, we see that there is a simple embedding layers, a bidirectional layer, dropout layer, and 2 dense layer. These 2 pictures shows the third and fourth architecture, which is the combination of embeddings and bidirectional. The first one is the Grove embeddings with bidirectional LSTM layer. And then we also insert a spatial dropout layer and 2 dense layer. The last graph is about the BERT and bidirectional LSTM architecture. We also insert spatial dropout layer and 2 dropout layer, 2 dense layer in this architecture.
We can break our project into 3 main parts: pre-processing, embedding, and methods. After struggling with the algorithm tuning and ensembles, we found pre-processing is as essential as the neural network. By removing special characters, changing abbreviation to what they are actually stands for, decoding emojis, and etc., we are able to achieve a better accuracy. Choosing the right kind of word embedding is halfway done. In this project, we have experienced BERT and Glove. According to our dataset, BERT returns a higher accuracy. Although bidirectional GRU and LSTM have higher accuracy compared with the unidirectional, Without the good word embedding, it cannot achieve a great accuracy. On the other hand, stacking models on top of each other may have the opposite effect. Thank you very much.
Thank you.